In today's lesson, Chapter 2, Section 3, we're going to talk about using postulates and diagrams. When I come here to the next one, plane point postulate, this is number 5, this says that a plane contains at least 3 non-collinear points. Again, this is the minimum number of points to create a plane. Okay, this is similar to the line point postulate that told you that you needed at least 2 points for a line. So again here, this is saying you need at least 3 non-collinear points for a plane. And number 6, remember these numbers, these numbers here don't matter, but the 6th postulate we're going to cover is the plane line postulate. And again, this says that if 2 points are in a plane, then the line that contains them is in the plane. So here you have a plane, here you have point A, and here you have point B. Well, if I happen to draw a line through those points, the line is also in the plane. So the line between A and B is the same plane as the actual points themselves. And the last postulate we're going to talk about today is the 7th postulate of the day, and it is the plane intersection postulate. And this basically says that if 2 planes intersect, then their intersection is a line. So think of this plane here, and then think about another plane drawn from that intersects this, like maybe a plane that goes, this goes behind it, this doesn't. And so you have these 2 planes, and you notice that the 2 planes are going to intersect at this line. Now it looks like it's a line segment, like it starts and stops, but remember that planes are really boundless. And so I know that these planes are going to go in every direction. So I know that the intersection is not going to be a segment, but rather a line itself, an infinite line. So another interesting thing here is about perpendicular figures. Now perpendicular figures intersect or meet at 90 degrees, which is a right angle. Okay, so a line is perpendicular to a plane if and only if, no, this is a biconditional, the line intersects the plane in a point. So the line intersects the plane in a point and is perpendicular to every line on the plane that intersects that point. So let's look at this image. What this image is telling us here is we have line P, and we have line Q, and we have line T. And in these 3 lines all meet here at this common intersection point. And so, again, a line is perpendicular to the plane. This line T is perpendicular to plane A. If and only if it intersects the plane in a point, which it does, it intersects the plane in a point, and is perpendicular to every line in the plane that intersects at that point. Notice it's perpendicular to line Q. Notice that this is telling me it's perpendicular to line Q. And if it's perpendicular to the other line P, and this one here tells me it's perpendicular to line P. Now we're going to apply what we've learned, and we're going to try to state the postulate illustrated by the diagram. And again, this is where, yes, I would like you to know the names of these postulates. However, if you can at least tell me what the postulates say, I would be pretty okay with that. So notice that you have this if-then statement. You have if, and you have 2 intersecting lines, and then you notice that it mentions in the then part, it has the point at which they intersect. So I know that this is referring to the line intersection postulate. And what this is saying is if 2 lines intersect, then they intersect at a point. Then they intersect in exactly 1 point. Or something to that effect, right? It's just basically saying, again, that two lines intersect in a point, and that's what that picture's showing me, okay? The next one, it's talking about two planes, and it basically says you start out, if you have two planes, then, and notice this, what it's showing you that they intersect in a line, right? So this is the plane intersection postulate, okay? And this is talking about if two planes intersect, right, then they intersect in a line. Here they want me to use the diagram to write examples of the plane point postulate and the plane line postulate. Now again, I need to know what these postulates are to be able to come up with an example. So the plane point postulate tells us that a plane contains at least 3 non-collinear points. So a plane contains at least 3 non-collinear points. So when I look here, I'm going to look at what's been given to me. And I notice that what I've been given is plane Q. And plane Q doesn't really have a lot of points on it. The only point that's on plane Q is A. So I don't have enough information here to actually name this point or identify 3 non-collinear points. However, plane P is a little bit of a different story. Plane P has point B, point A, so it has this line, and it has point C on the plane. So how would I show an example of the plane point postulate? Is if I said something like plane P contains, right, B, A, and C. Then I go to the next one, which is the plane line postulate. And what this one says is that two planes intersect in a line. Intersect in a line. And so when I look at this picture, I recognize that plane Q and plane P intersect at line M. And that's what the thing is just telling me, that two planes intersect in a line and a plane contains 3 non-collinear points. So that's how I show both of those. Here in this slide, we have to pick which of the following statements cannot be assumed from the diagram. And so when we look at this, the first one says A, B, and F are collinear. So point A, point B, and point F are collinear. Notice they're on this line that was drawn through them. And so this can be, it's a true statement, and you can make that assumption. Now the next one says E, B, D are collinear. And while they appear, E, B, and D, they appear to be on a straight line, notice no line was drawn through them. And therefore, I cannot assume that they're on a straight line. I know that any 2 points are in a line. So I know E and B are collinear. I know B and D are collinear. I know that E and D are collinear. But what I don't know is that those 3 points are in a line. And so this one, I cannot assume that this is true. Okay? So I cannot assume this one. Okay, the next one says, line AB is perpendicular to plane S. Well, to be perpendicular to plane S, line AB must intersect the point or the plane in a point, and it does, but it must also be perpendicular to all lines that intersect at that point. And I don't know that line AB is perpendicular to line BC. Okay, I know it intersects it, but I don't know that it's perpendicular to it. They didn't give me the symbol, and therefore I cannot assume this one as well. So cannot assume this, okay? The next one is another plane one. It says that CD is perpendicular to plane T. So again, I know CD intersects plane T, but I don't know that it's perpendicular to line CB either. And therefore, I cannot assume any of these, okay? And the last one says that AF intersects BC at point D. So line AF intersects line BC at point B. And this one is a true or a yes. I can assume that. So I can assume a couple, but not all of them. So here they're asking me to name a pair of supplementary angles and a pair of vertical angles. Remember that supplementary angles have a sum of 180 degrees. So every linear pair, for example, will be supplementary. So these two angles here, angle 1 and angle 2, form a linear pair, which means they're supplementary. So supplementary angles are going to be, for example, angle 1 is TWP, and angle 2 is angle PWV. That's one pair. Now, I can then find another pair of supplementary angles. I know that these two angles together, this angle 1 and this angle 2, form a linear pair. So another pair of supplementary angles is angle PWV and VWQ. I keep going. I can identify another pair, another linear pair in here. And again, let's call it angle 1 and 2. And I know that angle TWQ and angle QWV are also supplementary. And while we're at it, let me name the last pair. The last linear pair is these two angles. And let me tell you what those are. Those are angle QWT and angle TWP. So there I have 4 pairs of supplementary angle. I know it only asked you for 2, but there's 4, okay? The next one goes into vertical angles, okay? And remember that vertical angles, whenever you have 2 intersecting lines, they form 2 pairs of vertical angles. The first pair would be, let's say, these 2 angles, okay? And so those 2 angles are represented by angle PWT and angle VWQ. The second pair of vertical angles is this angle and this angle. And again, those would be represented by angle PWV and angle TWQ. And so there's 2 pairs of vertical angles. So these are the answers to those questions. Again, all of these, I can switch up the order, but notice they all have W in the center letter because W is the vertex of all of these angles. So even though, for example, let me just give you an example here. I called it TWP, it could be PWT. I called it PWV here, it could be VWP. I could swap the first and last letters, but the middle letter is always going to be in the middle, okay?